In this example, we will find all solutions on the interval 0 to 2 pi for secant of x is equal to 2 cosecant of x. We're going to keep all answers exact. Now for this problem, note that we are going to find all solutions on a particular interval, meaning that our final answer should not involve a full infinite solution set of plus 2 pi k. However, it tends to still be recommended to generate the infinite solution set, as you can usually come up with all the answers you need from that set itself. If you don't do that, you might end up losing some of the solutions, particularly for cases where you have more complex inputs inside your trig functions. This case, though, we have relatively simplistic ones, secant of x as well as cosecant of x. Unfortunately, those are not the same trigonometric function. However, when I see secant of x equals 2 cosecant of x, I do not happen to know too many identities that can allow me to replace secant of x with something involving cosecant of x, or that would allow me to replace cosecant of x with some expression involving secant of x. However, what we can do in this case, because there aren't too many obvious identities to apply, we could try to change these functions into sine and cosine functions. For example, secant I can reestablish as 1 over cosine of x. And that would equal 2 times cosecant, which is 1 over sine of x. At this point then, if I, because I see two fractions, say multiply both sides by something, I should be able to simplify this down a bit. For example, let's say if I take both sides of this equation and I multiply by sine of x. Well, on the right side, those two terms will cancel out. And on the left side there, I'll have sine of x over cosine of x, which equals 2. And sine of x over cosine of x, that is a quotient identity for tangent. So that is tangent of x is equal to 2. Well, that simplified the problem pretty heavily. Now I just have a single trig function equal to a constant value. I should be able to use inverse trigonometric functions in order to get x by itself. If I use arctangent in order to get tangent by itself, I will get, in this case, x equals arctangent of 2, which I'm just going to keep it as it is there because I do not know the ratio of 2 for tangent. I know the ratio of 2 for secant and cosecant, but not tangent. So arctangent of 2, we'll just keep it there. And then the full infinite solution set would be plus pi k. Now remember, the question did not ask us for the full infinite solution set, so this is not the final answer, but it can help us come up with the answers that we need. We need the answers between 0 and 2 pi, so let's use this to generate those. Starting with the first solution there, arctangent of just 2. This value, because of what we know about arctangent has to be an angle measure. So this needs to be an angle measure between negative pi halves and pi halves. And more specifically, because the ratio that we are working with here is a positive 2, that narrows it down even further, in that arctangent of 2 would have to be an angle measure in quadrant 1, or between 0 and pi halves. Now, if it's between 0 and pi halves, then that means it's between 0 and 2 pi for sure, so this angle measure works. Arctangent of 2 would be okay. We could also consider more solutions based on plus pi k. For example, if I add pi 1 time, arctan of 2, and I add pi once, Well, we had just said that arctan of 2 is between 0 and pi halves. It's between 0 and pi halves. And if I add pi to it, then at minimum, it'll be at least pi. And at maximum, it'll be at most, well, not 2 pi, 3 pi over 2. Pi halves plus pi. Well, if this is between pi and 3 pi over 2, then that means it's also between 0 and 2 pi. So this solution also works. If I try going any further, though, for example, if I do arctangent of 2 plus another instance of pi, which means we would now be doing plus 2 pi, well, that is going to give me a positive angle measure plus 2 pi, which means that is for sure going to be larger than 2 pi itself. So that would not be correct. For the angle measures between 0 and 2 pi, all we would need are these first two. So my answer here is x equals arctangent of 2 as well as arctangent of 2 plus pi.